Turn on the recording. We are being recorded right now. We are Chem8. Today is 25th of March 2021. Yeah. And we're going to talk about stereochemistry. So I'm going to draw that famous mirror. Okay. The famous mirror. Mirror, mirror, who is the most beautiful molecule? Shiny side, not shiny side. So I'm going to use like one example. I wish we had a little box here. I'll just continue to use the sphere. Okay. We have a sphere. Okay. And if we have, let's use a different letter. How about A, B, C, D, E, F, G, H, a symmetric letter, but not, let's use a funny symmetric letter. What's a funny symmetric letter? Like symmetry, vertical symmetry. So the left and the right of that letter are identical. Give me something that's a little unusual. What's an unusual symmetric letter?
U.
Sorry?
U.
U, okay, U, sure, U. That actually will start to look like a cat eye. You know, let's use a different color. What color shall I use for the U? Maybe red, like an angry eye. Looks good. What's the relationship between the sphere with a U written on the left and its mirror image on the right? Are they superimposable? Yes or no?
Yes.
Yes.
Okay, so they're identical, right? So let's try to make it a little funny. Like a double arrow, not Amazon arrow, but then I'm definitely not doing a really good job in drawing this. Okay. Yeah, so they are superimposable. Superimposable. That means they're identical. Okay. So they are identical. Okay, they are identical objects. Let's use another one. Let's use a different color, and this is where our object analysis will end. Okay, give me an unsymmetric letter, no vertical symmetry, something unusual. Tell me something. You guys know the alphabets better than I do. Any suggestion?
K.
Sorry?
K.
K? Sure, K. What color shall I use? K, maybe black. Black and green. There's a reason for me to act weird, okay? I think I have, don't answer too quickly. Think about it. I think I have a K written on one of these guys. Yeah, I do have it. And we're going to pretend that it doesn't have that little stem, okay? It's a perfect sphere. I don't want to torture it right now. Think logically, think rationally, then give me the right answer. What's the relationship between the perfect sphere with a K written this way and its mirror image sphere with a K written this way? What's the relationship between them? think. It's not the obvious answer that you're thinking. What's the relationship? Are they superimposable or are they not superimposable? I give you 1 minute, 1 full minute. Anybody wants to chime in?
Are they superimposable if they're rotated? Like if the flat side of the K was on the bottom?
What's your major, Amelia?
Pre-vet?
You should become a chemistry major. You're thinking like a chemist. Well, you're thinking like how is your sense of navigation? Pretty good?
Yeah, I do well in chemistry.
Chemistry minor. Okay. Yeah, so ignore that. Ignore this stem because that screws up everything. That breaks the symmetry. Imagine it's not there. Okay. So that's the K, right? And where is my other K? And that's my other K. Okay. Right? So mirror image. So they are not superimposable if I put them this way. But what if I turn the sphere? They are superimposable. So there is symmetry. Okay. So if you turn it upside down, then the way it's drawn here, they're superimposable. So Amelia is absolutely right. They are superimposable. They're not, there is nothing going on with the symmetry. So they are superimposable. That means they're identical. Okay, it's a different story. It's a different story. I'm going to expand this story. It's a different story if there is a stem on it. I wish I was a better artist, sketcher. Okay. It's going to completely change the scenario. If there is a stem. These two guys are not superimposable, not superimposable. That means they're different. They're not, they're completely different species. Okay, it's like this. If I now ask you to do consider the stem, right? I hope you can see the stem. Now the K is written and they're mirror images. Let me see how it is looking in on my screen. So now when you're trying to superimpose them, you see you cannot superimpose because the stem cannot superimpose on this stem because in one case it's down and in the other case it's up. Make sense? So once you add the stem or add something else in the molecule, what you're doing is you're basically messing up the vertical, the horizontal symmetry. Excuse me, symmetry. In this case, this guy has horizontal symmetry, right? It's got this symmetry that you cannot, it doesn't have vertical symmetry, but it's got horizontal symmetry. The top and the bottom are identical. That's why if you turn it upside down, if you turn it upside down, it looks the same. But if you, by adding the stem, what you're doing, you are basically screwing up the vertical, the horizontal symmetry. You're making the bottom look different than the top. That's why. I'm going to pause for like a few seconds and make sure that this is sinking. What we have just done. Then we're going to go into the real molecule and we're going to start analyzing them. And that's what I want to accomplish today. And I'll introduce that phrase, like what are those guys called when they're not superimposable, but they're mirror images, like your hands, like your like my ears, like my eyes, kidneys. We have 2 lungs. They're mirror image, but they're different. Like the two thumbs, they're mirror image, but they're not superimposable. So let it sink for like half a minute. So our next step is moving into molecules. Like what kind of molecules, what kind of properties the molecule must have to start showing this non-superimposable mirror image relationship. Any questions at this point? Okay. So this property is directly linked with symmetry of the molecule. If there is symmetry, they're superimposable. If there is no symmetry, they're not superimposable. Okay, let's start with some molecules. We are moving into the molecular scenario. All right. So do I have 8 blue bars? 1, 2, 3, 4, 5, 4. I don't. There's nothing hidden anywhere. Okay, that's fine. Okay, I'm going to draw the carbon hydrogen bonds in black color. Molecule number 1. We're going to start with methane. Molecule number 1. Methane, right? This property can only be acquired by a carbon or a molecule when there is an sp3 carbon. It doesn't work with sp2 or sp carbons because they're flat. This property of non-superimposability, there has to be some depth. The molecule has to have some, I don't want to use the F word. I'll tell you which F word I'm thinking. Fat. I don't want to use that word. The molecule must have some depth in it. Okay, 3-dimensional presence. Okay, so sp3 works for this property, to acquire this property to be non-superimposable. sp2 and sp don't work. Okay, so let me draw its mirror image. How do they look like? I'm going to try to put them in the same place. I'll do my best to draw the best, as good molecule as possible, but it's probably not going to be that good anyway. Okay, so you can tell probably that you can probably tell what the result is going to be, whether it's going to be superimposable or not. Okay, so before you say something, let's just make the molecule and go through the process. I know that you know the answer. I am pretty confident that you already know what the answer is going to look like. Okay. Since it was in a, since the molecule was in like a cyclic molecule form, everything bent over the last couple of days. I think this looks good. Okay. Methane. You guys are happy with this methane? And that's its mirror image. This is bent. I want the bonds to be straight so that it doesn't cause any additional confusion. Okay. Mirror image, right? Left is the molecule and right is the mirror image, right? What do you guys think? If I try to superimpose one on top of the other, do you think that everything is going to lay on top of the other molecule? Are they superimposable or not? What's your gut feeling before we do the experiment? Yes or no? If I try to put the carbon in the middle, and if I try to lay the hydrogens on the top and all the 4 hydrogens, do you think the real molecule will look like its mirror image?
Yes
Yes or no? Come on, wake up.
Yes.
Yes. Who
Yeah.
said that? Amelia?
Yes,
Okay.
it would.
If I try to superimpose, Georgiana, thank you. If I try to superimpose, you can tell, maybe you're a little confused, like what exactly I'm trying to do. I think once we could go through a little more process, it'll probably start to make more sense. You can tell that the 4 hydrogens and the central carbon, they're falling right on top of each other. If I could really use like a 3-dimensional picture on the computer screen, you could see that they start to look like one molecule once I put one in the other, right? So the relationship between them is their mirror image, Mi, like them, like they're all mirror images, the relationships. Their mirror image and they're superimposable. Okay. This one is their mirror image, but not superimposable. These 2 guys, right? So these guys are mirror image and superimposable. So they're identical. Okay. Now let's start messing with the molecules. Let's just change 1 hydrogen at a time. Okay. So let's do this. Now let's change this molecule to kind of here. Let's keep the hydrogen here unchanged. Let's keep this guy unchanged. Let's just change one of them into something else. Let's change this one into I don't know. Let's use like pretend that we are using 3 different elements. Okay, fluorine, chlorine, and bromine. How about that? We're going to call it. We're going to make the fluorine. We're going to use different colors. Okay. For fluorine, I want bromine to be red because bromine is red. So let's use bromine as red. So bromine will be red. Chlorine will be purple. And fluorine will be green. Not that fluorine is great, but fluorine actually is present in many molecules, many drugs, many medicines. By itself, fluorine is bad. Fluorinated compounds can be really terrible for the environment. It causes the hole in the ozone layer. But then when we replace a hydrogen with a fluorine, it doesn't have to be a toxic compound. It's an interesting, it's like how you're incorporating fluorine and the halogens, that's important. Like some compounds, some drugs have fluorines and chlorines, okay, and they're fine. I can think about one molecule. We're working on that actually for an not artificial intelligence, anti-infective project and an antifungal project. And there is a molecule called lotrimine. You probably have heard about it. It's an antifungicide. It kills fungus and it has a chlorine in it. It's a pretty interesting molecule. It has a lot to do with carbocation stability and how can you increase the carbocation stability and decrease the carbocation stability. It's a very interesting molecule. We'll talk about it sometime later. Okay. So one of our new projects that 2 of my undergraduates are beginning to work with. I mean, you might know Michael Coppage and Wesley Hatcher. Wesley has been kind of pioneering that new project. It's a collaboration with Dr. Elia Muni in biology. Okay, so we're going to switch. We're going to make one bond different. Which one? The one on the back. So let's convert that into a bromine. So let's change it into a bromine. I'm going slow because some of you may be gifted with this understanding of three-dimensional shapes and sizes. Some of you may not be very gifted. Okay, I have mentioned it, like I have told you, like I can see molecules, but I'm terrible when it comes to navigation. All right, so I'm going to switch one with a red bromine. So a black goes away and the red comes in. Okay, so the name of the molecule will be, can somebody name it? What should be the name of this compound? Well, I haven't taught you, so it's pretty unfair. So when bromine is there as a group, it's called bromo. So if it is bromo, if I tell you half of the story, if this is bromo something, what should you call it? Bromo what? What should be the name of this molecule? Bromo something. The alkyl group. Where did that come from? Which alkane did it come from?
Methane.
Thank you, Harpreet. Bromomethane. Okay. I'm not going to show you the model. I'm going to be unfair and I'm going to be kind of not being mean, but I'm just not going to show you. What do you guys think? The bromomethane on the left side and the mirror image bromomethane on the right side, do you think they're superimposable or do you think they're not superimposable? Somebody who has not answered today, try to answer. Not Georgiana, not Amelia. I believe Nathan might have answered and Harpreet has answered. I don't know if Nathan has answered. I don't know. I can't remember. So bromomethane on this side and its mirror image, are they superimposable or not? I'll show you the models. This is what the models look like. Let me hold it from the top, like I'm hanging, so that you guys can see. This is how they look like. If I try to lay the black hydrogens, the central carbon, and the bromine together, I'm trying to twist your brain. I'm trying to force you to kind of rotate the molecule in your head and imagine that you are putting the red on top of the red and the central carbon on the central carbon of the other molecule, and then see what happens to the rest. What do you guys think? I'm going to take away the models again from your vision. Do you think that these two guys are superimposable or not? Anybody? Anyone? Doesn't matter if you have answered today.
I think they can be if the bromine is facing the facing us.
It doesn't matter, right? I mean, two molecules are either superimposable or not. It doesn't matter how you hold them. So the task is that this is the molecule, this is one molecule, and this is the other molecule, right? If I try to lay one on top of the other by turning it, I'm not going to be doing something weird to check their superimposability. Oh, they're not superimposable. That's not how you check it. You try to align one object over the other, you twist and turn and do everything so that every body part matches. So what do I do first? Well, I should probably try to align the bromines. What do they look like? Do they look like they're superimposable or not? Yes or no? I want to hear it from few of you.
Yes,
Yeah.
I agree.
Yes.
They're superimposable, right? So when you have three identical groups, hydrogen, three hydrogens, and something else, they're superimposable, right? So the relationship between these two molecules, their mirror image, Mi, and also they're superimposable, that means they're identical. Okay, these two guys are also identical. Okay, now, next, let's mess with one more hydrogen. Let's change the second hydrogen and see what happens. So I'm going to draw them down here. I thought I heard some alarm. That's the bromine. Let's put the chlorine. Chlorine is supposed to be purple color. Let's make that change in the, okay? So that's how the molecule looks like. That's on the top, that's hydrogen. This is bromine. I'm going to switch this guy with the purple bromine, purple chlorine. Okay, this is how it looks like. Okay, that's this. I don't know if you guys can see it. Yeah, you guys can barely see it. Now I'm going to switch this other one. The other one, so this is how the molecules look like. Yeah, I can let's see. Okay. Right? Sorry. I'm not holding it right. Yeah, now I'm holding it right. Okay. This hydrogen and the bromine are on the whiteboard. The chlorine is sticking out, and the other hydrogen, this hydrogen, it's sticking, it's behind the whiteboard, right? So let me move the chair forward. I really don't need the chair anymore. This is how it looks like. What do you guys think? When we have two hydrogens and two different groups, do you think the relationship between this molecule and this molecule, it should be called something? We can try to name it later on, but I am not so interested in naming the molecule. I'm more interested in teaching you about this relationship between mirror images. Do you guys think they're superimposable or not? Who can do that superimposing experiment in your head? Who can do it who can do it mentally? Do you guys think they're superimposable? Yes or no? And then we can practice. Then we can try to lay one on top of the other and see if they're superimposable or not. Anybody wants to make a prediction?
They're not superimposable.
Edgar, what can you speak a little loud? Okay, sorry, my bad. My volume was too low. Edgar, can you repeat one more time?
Yeah, they're not superimposable.
They're not superimposable. Okay. Edgar says no. Anybody else? Who is good with who can see things from different angles, like imagine stuff? Anybody else wants to pitch in, chime in? So if I try to lay the purple on top of the purple, the red on top of the red, do you think the blacks will line up?
Yes.
Georgiana, what do you think? They're superimposable?
Yes.
Anybody
Yeah.
else? So Georgiana says yes, Edgar says no. Should we have two groups? What do you guys think? Can somebody else pitch in? Can someone else make an opinion or make a prediction? Sorry.
I think they're not.
Harpreet, they're not.
No.
I believe they are superimposable.
Cassandra says yes. Okay. Now we are 2-2. We are growing our Republican and Democratic parties. Anybody else? Superimposable or not? Some of you are going to feel really terrible.
I think they're superimposable.
Vincent, superimposable. One more person. I just want to hear from so we have 3-2 now. Are we going to tie, or are we going to, or is one group going to win? Sixth person. Anybody wants to say superimposable or not? Come on, hurry up. Say something. Talk to me.
I think they're not.
Jeanette. So it's 4-2 now. Do you think this voting is representing the right answer or wrong answer? Okay, let's try to superimpose. Okay. Oh no, they're not superimposable. Is that the right way of superimposing them? Let's try to put the red and the purple on top of each other and see if the blacks superimpose. Well. Some of you should be feeling bad, but then don't feel too bad. Don't kill yourself. It's okay. So they are superimposable. Do you know why? Do you know why they're superimposable? Imagine this plane. I'm going to look for a white sheet of paper. Hold on. I'm stealing from my stack for my printer. Hold on just a second. I don't want to. I'm always afraid that someday my shelves are going to come down. So if you think about this, let's do this. This is my makeshift model kit. Yeah, I'm making a mess. If you think about this plane, the plane that holds the central carbon and the bromine and the chlorine, if you think about this plane, that's a symmetric plane. Okay, that's a symmetric plane because the hydrogens are on the two sides, like one here and one here. That's a plane of symmetry. Do you guys see that? That's a plane of symmetry. The plane, the surface that's holding on to the bromine, the chlorine, and the central carbon, that's a plane of symmetry. Therefore, they are superimposable because that's why, you know, there is some symmetry in the molecule. This is not a symmetric plane. That's a wrong plane. The plane that holds on to that contains the carbon and the two hydrogens, it's not symmetric because it's got a chlorine on one side and a bromine on the other side. They're not mirror images, they're not same. So there is no symmetry here. There is symmetry here. This is a symmetric plane, okay? So the relationship between these two guys is also their mirror image and they're superimposable. That means they're identical. All right, last molecule. Okay, bromine here. Bromine here, chlorine in the front, chlorine in the front, and let's put the fluorine on top. Fluorine on top, okay. So now we need to find two green sticks and, okay, so this guy has to go. Looks like this molecule, right? I didn't screw up. So the hydrogen is in the back, chlorine is out, the fluorine and the bromine are on the whiteboard. All right, where is my other model? This guy will be bromine, chlorine, hydrogen. What do you think the relationship between these two molecules are? Let me hold it this way. I don't know how it's gonna project. What do you guys think? So it's got a fluorine on the top, these two, those are the bromines, and these are the two chlorines, and there is a hydrogen. So each carbon has 4 different things attached. Do you think they're of course mirror image, right? That's the mirror image. The hydrogens are mirror images. The chlorines are mirror images. I mean, the locations are perfect, right? Fluorines are mirror image, so they look like mirror image. This is exactly how the mirror image of this molecule will look in the mirror. Okay. Now, if the mirror image could become a real molecule, what do you guys think between their relationship is? Are they superimposable or they are not superimposable? So they are definitely, their relationship is they're definitely mirror image. Definitely mirror image. What do you think about the superimposability? Let's try. Okay, let's try to superimpose. Let's try to superimpose the fluorine and the bromine. Okay, I superimpose the reds and the greens. The chlorine and the hydrogen, they don't match, they don't superimpose. Let's try to superimpose the chlorine and the hydrogen and see what happens. When I try to superimpose the chlorine and the hydrogen, oops, the fluorine and the bromine, they don't match. Okay, if I try to superimpose the purple and the green, okay, I superimpose the purple and the green, the chlorines and the fluorines, the bromine and the hydrogens, they're not superimposable. So what's the outcome? What should you say? Are they superimposable or not?
No.
They're not superimposable. So they are mirror images, but not superimposable. And that's a big deal. Why they're not superimposable? There is no symmetry. If you consider the plane that contains the bromine and the hydrogen and the carbon, oops, the two sides have two different things. It's not a symmetric plane, right? Left side you have a chlorine, right side you have a whatever that is, fluorine. If you take this plane, the chlorine and the fluorine plane, different things on the two sides. If you take this plane, different things on the two sides. So no matter how you try to find a plane of symmetry, there is no plane of symmetry. Like our hands, no plane of symmetry. Like my eye, there is no symmetry. No symmetry whatsoever, right? The two lungs, the two kidneys, my toes, my elbows, my arms, ears, they're not superimposable with their mirror image because they may look like they are mirror images, but there is broken symmetry. They don't have any symmetry. So when an sp3 carbon has 4 different things attached to itself, the molecule and its mirror image are not superimposable. They have different stereochemical properties. Let it sink for a while, and there is a name for it. So there has to be 4 different groups or atoms or something attached to that central sp3 carbon. It has to be a tetrahedral carbon here, here, out and in. Only then you can develop this property when it's not going to be superimposable on its mirror image. Okay, look at this. Just make sure it sinks. This may be very easy for some of you. It may be very difficult to fathom or imagine for some of you. So those of you who are having hard time, feel free to ask questions. You're not going to look like, I'm not going to lower my opinion about you, okay? And this is totally normal. It's how our brains are wired. There's nothing to be apologetic about or feel bad about. Take a look at it for a few seconds. Any questions? I'm going to introduce some definitions right now. Okay, unfortunately I don't have enough space. I'll try to fill in different nooks and corners. Okay. Number one, I'm going to start writing in the corners with bullet points. When two molecules are mirror images and not superimposable. Very important. When two objects are mirror images but not superimposable. Not superimposable. They are called enantiomers. E-N-A-N-T-O-T-I-O-M-E-R. They're called enantiomers. E-N-A-N-T-I-O-M-E-R. Enantiomer. You can break it down. Enantiomers. Okay? So they are not enantiomers. They are not enantiomers. These two guys are enantiomers. Okay? This molecule, which has 4 different groups attached to itself, those guys are enantiomers. Okay, that's bullet point number 1. That's a definition. You learned something today. They're stereoisomers. Okay, they're one of the stereoisomers in the stereoisomer family. They're stereoisomer. They're stereoisomers. Let it sink. So 2 objects, my left hand and my right hand, they're mirror image. The relationship is their mirror image. They're not superimposable. They are enantiomers. 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 My toes, enantiomers. My knees, enantiomers. My kidneys, enantiomers. My lungs, enantiomers. That's the relationship. But they have to be perfect mirror image. Okay. So take it with a pinch of salt because, of course, my left ear and right ear are not perfect mirror image. But let's assume that they're perfect mirror image. When they're perfect mirror image and they're not superimposable, the relationship is called enantiomers. It's under stereoisomer. Make sense? I'll pause for like 15 seconds. Make sure that it syncs. Second bullet point. I'll try to fit it in here. Second bullet point is an sp3 carbon must be bonded to 4 different groups. 4 different atoms or groups to be enantiomers. To have this property, it must be, this is very important, it must be attached to 4 different groups. If it is attached to 3 different groups, hydrogen, bromine, and chlorine, it doesn't cut it. If it is attached to 2 different groups, bromine and hydrogen, doesn't work. It has to be attached to 4 completely different groups, but it could be hydrogen, methyl, propyl, and ethyl. That counts. We will do some experiments, okay? Hopefully today, okay? So that's the sp3 carbon. This is also important. It has to be an sp3 carbon, a tetrahedral carbon. Sometimes other elements work, but we're not going to discuss it within Chem 128A and 128B. Phosphorus works, sulfur doesn't. Sulfur works, nitrogen doesn't work. Okay, if you have, let's not talk about it right now. I don't want to confuse you. Okay, so far so good. Are you guys following everything? This is something that can be very abstract for some of you. So if you're not following it, ask me questions. I have deliberately slowed down just a little bit to make sure that this is totally understood by everyone in the class. I'll pause for 15 seconds. Fifteen seconds over. Any questions? Anybody? One more definition. When you have an sp3 carbon attached to 4 different things in here, okay? When you have that requirement fulfilled and it has its mirror image and they are not superimposable and they are called enantiomers, that central carbon is called a chiral carbon. Down here, I'm going to add one more bullet point. The central sp3 carbon, which is attached to 4 different things, I'll just put it in parentheses, 4 different groups attached. Sorry. Groups attached, groups are atoms attached. The central sp3 carbon is called, important, chiral carbon or chiral center. Big deal. This is an important deal. The central carbon is called chiral carbon or chiral center, and it's often written with an asterisk. So that central carbon will get an asterisk, like a star. So we put like a little star here, the chiral carbon. Okay? And gets a star like this. That's just to denote that star indicates it's a chiral carbon. Make sense? I'm going to pause for another 15 seconds. I'm pausing quite a few times today because I want you guys to completely understand what's going on here. I'm going to take a picture now. I don't think I have anything to fill in that hole, like little empty space. That's not my point. I'm just trying to show you some of the definitions. The bottom line is for two molecules to be called enantiomers, they must be not superimposable on their mirror image. That's the definition. I'm going to write down the definition of enantiomer one more time after erasing the board. What kind of molecules can depict? I mean, can demonstrate this property? Well, it has to be an sp3 carbon, has to be a chiral carbon, has to be a tetrahedral system, and the tetrahedral in the tetrahedral system, that one carbon has to be attached to 4 different things to be chiral. Okay, chirality has something to do with broken symmetry. I think if somebody knows Greek or Latin, I don't know where it came from. It has something to do with symmetry. I don't remember exactly that history right now. Okay, that one carbon in the whole molecule has to be attached to 4 different things, and then it will be not superimposable on its mirror image. Okay, I'm going to take a snapshot fairly soon. Let's take a picture. I'm going to block the camera one more time. You guys are okay? So far, so good. I'm assuming silence means good. Okay, so I'm going to draw this molecule one more time. So don't worry, I'm going to keep it for a second so that I can draw it a little bit bigger up there. Same molecule, the chiral molecule, the enantiomeric molecule. And I'll just keep them so that I don't make a mistake in kind of reproducing that same structure one more time up here. Okay, so let's redraw this molecule and I'll erase it again. Erase it from down here. Okay, so let's draw a smaller mirror this time. That's the mirror. And let's draw this guy. Hydrogen. Hydrogen. Let's put a circle because the hydrogen is hard to see. It looks like the dashed lines. The bromine is here. The bromine is here. Chlorine is out. Chlorine is out. And fluorine is up. Okay, so that guy can go. The structure can be erased now. I don't need that anymore. Okay, so their relationship is, let's write down some bullet points. Number 1, sp3 carbon with 4 different groups. Number 1 bullet point. What do we see? They're both sp3 carbons. These carbons are sp3 and it has 4 different groups or atoms. All right, number 1. Number 2, second bullet point. The molecule is not superimposable on its mirror image. Bullet point number 2. Bullet point number 3. The molecule lacks symmetry. And then another fact, like another fact of the matter, is that the molecule and its mirror image are stereoisomers and called enantiomers. They're called enantiomers. These two guys are called enantiomers. The central sp3 carbon is called, I'm kind of summarizing everything, is called the chiral carbon or chiral center. What else? I can't think about anything else. Chiral carbon, chiral center, andron, and a star like this, asterisk, indicates that. Okay, we put like a little star here. Okay, what else? I think that's it. Yeah. So if I twist it a little bit, if we go backwards, what's the definition of enantiomers? The definition of enantiomers is, what time are we at? 1:31. I'm going to let you guys go in like 4 or 5 minutes. The definition of enantiomers is 2 molecules mirror images of each other, but not superimposable. In one word, if you want to just say quickly, like if I asked you, and if you don't want to write the whole sentence, because you know that I like short answers, you can say, what is the definition of enantiomer? Well, non-superimposable mirror images. That's the definition of, if you want to write the minimum to please me, not write too much, that's the definition of enantiomers. We're going to experiment. We're going to continue our discussion after the spring break. We will have the long test, full test. We're going to continue discussing stereochemistry on the Thursday, and the quiz and the exam will be on the Tuesday after spring break. Next week is spring break, so don't show up. Don't show up in front of Zoom, and hopefully you guys will have some, you can relax, charge your battery and get some rest and have some fun and do some study. Please don't just completely blow it. And I'll make the video and everything else available as soon as I can. I think I'm going to call it a day. I promised you that I would let you guys go a little early, so I'm letting you guys go 12 minutes early. Oh my God, now I'm having second thoughts. No, that's the final decision. Have a good spring break, guys, and take care. And if you have any questions, I'll be around. I might take the last part of spring break off. I might go for a long drive. I have a very strange, weird car. You probably haven't heard about that name. So I want to take that car and go for a very, very long drive, listening to my old 80s cassettes and CDs. And just, you know, brings back memories when you guys are not born. All right, take care, everyone. Anything else? I can hang in here for a few more minutes. If you have any, yeah.
Hey, Professor, I wanted to ask if it would be possible if we could have a second attempt for our quizzes.
No, sorry, answer is no. If you want, this is what I can do. Okay, what I can do is I can drop, let's say you took 3 quizzes, right? And this is going to be discussed at the very end. If you think you have done really poorly in one quiz, I can drop that quiz and give you an average of quiz 1 and 3 or 1 and 2 or 2 and 3 for the bad quiz. How about that? That might raise your percentage a little bit. Okay, so I'm gonna I'll take that extra pain and trouble to do that. You're not happy, Sahar?
Bye.
I am, but I feel like it would just be better for us to have a second attempt and like learning wise, because if the questions that we get wrong, it's not going to show us the right answer. So we're going to go work on it again and get it right the second time.
I appreciate the feedback. What I can do is I can open up the quiz so that you guys can see where you went wrong, and I can actually upload a little video of how the quiz should have been answered. We can go over that. That'll help you. I'll tell you this. Three quizzes, right? I do it only for 4 quizzes when we have 4 quizzes. I can drop your worst quiz. That's all I can do. Okay? If you have got a pretty bad score in one of the 3 quizzes, I'll drop that score and adjust everything else accordingly. I can do that. I'll make an announcement so that you guys can have some relief and not get too anxious about one bad quiz. But make sure that you do a good job in the second test, the third quiz, and the final. Okay.
Okay. And for our second test, are we going to have like a study guide that we could study from?
Study guides are the videos and the still pictures. I don't have any plans to do any review because it's synchronous and asynchronous. So just study them and that should do it. You can always ask me questions. You can always request office hours from me, and I'll make an attempt to sit down with you and go over anything you want. And that can be during the weekends at odd times whenever you're available. So that offer is always there. So make use of that offer. Okay, that's your study guide. I mean, I will spend as much time as you want with you. So I'll stand by my promise.
All right. Thank you, Professor.
Bye. Have a good weekend and have a good spring.
Bye.
Take care. Anybody else? Any other questions? Brendan, Harpreet, you guys are doing well?
Yep, doing pretty good.
Okay, we'll talk.
If you can just open the quizzes so we can know where.
Yeah, I will do that. Yeah, I'll do that.
Thank you.
Thank you. No problem. Take care. Have a good spring break. Bye.